Hello, everyone, and welcome to part two, where we will be looking at the chemical reactions of alkanes. Because the CH bonds are strong, alkanes are not very reactive. However, they are used as fuels in combustion reactions. So let us see an example of this reaction. Let's take a simple alkane, so methane, so one carbon and four hydrogens. In a complete combustion, we have an excess amount of oxygen. And this kind of combustion is called complete combustion. In a combustion reaction, we make CO2 and water. Okay, to balance the equation, of course, we need 2 there and a 2 here. So this is a complete combustion reaction, exothermic. Okay, however, there is a possibility of having an insufficient amount of oxygen, which is called an incomplete combustion. Now, the products may vary, and you will see different things in textbooks, but there are 3 possible products. You could make some carbon or carbon monoxide. So I'm just going to put those 2 products, and water, of course. Now, in a laboratory, if you use a Bunsen burner, a safety flame is going to be yellow because of the production of carbon. You're doing incomplete combustion in that case. Whereas the roaring flame, where the air hole is completely open, you have sufficient oxygen, and that is called complete combustion, and we have a blue color. Now, there's also a variety of ways you could balance this equation, depending on how much carbon or carbon monoxide you make. So this will vary. Apologies. And therefore, we will have a variety of balanced equations. So this is an important point that a lot of people get confused about, is that when we balance these equations, sometimes we can use fractions in front of the oxygen, because now we have 5 oxygens on the right and only 2 on the left. So we are allowed to put 2.5 or 5/2, which would make 5 oxygens on the left too. So here we have 2 of the basic reactions of alkanes, complete and incomplete combustion. Now, a slightly more complicated reaction of alkanes is halogenation, is a substitution reaction where we replace a hydrogen or more than one hydrogen with a halogen. Now, to do this reaction, we need some special conditions. For example, let's take chlorine. Because the chlorine bond can be broken with UV light, we use UV light. And we form 2 species called radicals in chemistry, where a species has a single electron by itself. Now, more detail on that in the IB videos. But what happens when you react CH4 with chlorine in the presence of UV light? So the UV light is to break this Cl bond and form a radical, which is very reactive and causes the replacement or the substitution of 1 hydrogen with a chlorine or more. Okay, it's not easy to control this reaction, so you could replace all of the hydrogens with chlorines. But in GCSE, we could keep an easy example: replace 1 hydrogen with a chlorine, and the remaining hydrogen goes with the remaining chlorine. So this is a substitution reaction, also called a free radical substitution, because of this single electron here, which is called a radical species. So these are the 2 main reactions of alkanes.